In the last video, we learned about the conditional distributions for contingency tables or two-way tables. And we want to kind of explore those conditional distributions just a little bit more because something very interesting shows up called Simpsons Paradox. So we're going to look at these real data. These are the data that show the results of whether the death penalty was imposed in murder trials of convicted people in Florida from 1976 through 1987. So these are all people that are convicted of murder. So let's be clear on that. So all of these are convicted of murder. And what we've done is we've aggregated the data. So we have all the Caucasian murder convicts here on the top row and all the African Americans aggregated here together. Aggregate means you push them together. All right, so what's the total number of defendants? So in this group, it's 483. And I'm getting that, but just by adding those two numbers, 430 plus 53, let me write that up, 430 plus 53 is equal to 483 total. All right, now for the African American people that were convicted, it's 15 plus 176, which is equal to 191 total. All right, so now we're going to find the probability they were given the death penalty. And we're going to do it across the row. So we're going to presume the defendant is Caucasian for the first row, and then presume that the Caucasian or the defendant is African American for the second row. All right, so since we're working across the row, we are assuming that we're Caucasian, like I just said. So that means that we're given that, if you want to say, or by the fact that, or by by ethnicity, by race. So we want to look at this in terms of, look at this total row. The total for the row is 483. So we're going to take 53 and divide it by 483, which means 10.97% or 0.1097 of the 10.97% of the Caucasian defendants were given the death penalty. Now, if we do the same thing down here, we would take 15 and divide it by 191. So when we do that, 15 divided by 191 is 0.0785. 15.0785, which would be 7.85%. So it appears that African American defendants are less likely to receive the death penalty in those years. So let me type that up. There. It appears that Caucasian defendants are slightly more likely, which is 10.97% versus 7.85%, excuse me, to receive the death penalty in Florida. I should say than African American defendants. Now, appears is kind of the key word here, because you think this is really cut and dry, but it's not. And part of the problem is that we have aggregated this data. This is mushed together different types of crimes. So we are going to disaggregate that data. We're going to separate it out, right? And that's what we're going to do down here. So note these data are aggregate. And that's going to be key, right, to this. Okay, they're aggregated, they're smushed together. / mushed together. So now we're going to separate it out. All right, so let's look at this. We still have 53 Caucasians right here received the death penalty, 414 for no death penalty. Okay, so what this is a Caucasian person killed another Caucasian person. There are 53 death penalties out of 414. So the total number of defendants that are in this class is 467. So let me type that up. And I did it for the rest of the rows as well. So I can see that I had, for an African American defendant who killed a Caucasian person, I have 11 and 37 here. So I add those up, I get 48. For a Caucasian person killing an African American person, there were no death penalties applied and 16 convicted. So that gets you 16 defendants total. And then African American killing another African American person is 4 death penalties and 139 no death penalties. That gets you 143. Okay, so now let's look at the probability if they're given the death penalty. So for this first one, it'd be 53 divided by 467. So you can see that that gets you a percentage of decimal, excuse me, of 0.1135 or 11.35%. I'm taking the 53 and divide it by 467. Now just on a side note, realize that this works out. 53 and 0 makes this 53 up here, and 430 can be built by taking the 414 and the 16 right here. So these are the same numbers as before. They're just broken up, right? We're breaking them apart. We're disaggregating them. All right, so now for this next group, I'm going to take 11 and divide it by 48. And then I'm going to take 0 and divide it by 16 and 4 and divide it by 143. There we go. Now we have all the percentages. So now you can see that it shows a different picture than what we were seeing before. So the disaggregated data, let's look at it for a second. So let's consider if the victim was Caucasian. If the victim was Caucasian, then African Americans are twice as likely to receive the death penalty as another Caucasian person. Interesting. If the victim was African American, Caucasian people are never assigned the death penalty. That's interesting. And also, African Americans are not assigned the death penalty very often. That's fascinating. Now notice, again, just reiterate, these are the same numbers as before, right? It's just that it's showing it in a different way. 4 plus 11 still makes 15. These are the same numbers, but when you break them apart by the victim's race, right, using that as a lurking variable, if you will, when you split the data apart that way, then it gives you some very interesting comparisons, right? So for example, this 11.35% and the 0%, right, for Caucasian Caucasian defendants. Or let me undo this one. I just thought of this. We should compare these two right here, right? African American is twice as likely to get the penalty, death penalty, excuse me, as a Caucasian Caucasian defendant. Excuse me. And then here, African American is more likely, first of all, but neither one of these is very likely. So I'm not sure what that means about African American victims, but I don't think it can be good because it's showing that we don't assign the death penalty very often when the victim's race is African American, but we do when the victim's race is Caucasian. So let's make some notes of that. So this first question is just saying what appears to be happening now. Well, it appears that African American defendants are more likely. Remember, that is not how it originally appeared. It at first appeared that Caucasian defendants were more likely because when you push all the data together and shove it together, there were more of them, right? So you had 483. So the death penalty was happening 11% of the time versus 7.85. But now when we break the data apart and we actually compare them, blue to blue and green to green, you can see that the African American defendant is twice as likely to receive the death penalty. And here, well, it's 2% more times the death penalty, but of course 0% is really, really low. And so that's what we're seeing. So we're seeing the two blue numbers and the two green numbers and how they compare, right? So, and either way, it's looking like the African American defendant is more likely to receive the death penalty. All right, so what's happening? This is called Simpsons Paradox. It's when two variables seem to be related in a certain kind of way, but when a third hidden variable is taken into account, like a lurking variable, so in our case, the victim's race is taken into account, it breaks the data apart in such a way that you're able to kind of explore what's going on in the background. And you can see that there is actually something else going on that you couldn't find out in the first place. You have to pay attention to how you develop these studies and how you break apart the data. So let me type all that up. There you go. So when we disaggregate, i.e. break up the data based on the victim's race, we get a better sense of what's actually happening. And we find that the African American defendants are in fact more likely to receive the death penalty. In other words, paying attention to the lurking variable of the victim's race reversed the likelihood of the death penalty application. This is straight up Simpsons Paradox. It shows us that you want to pay very close attention to your data and make sure that there aren't lurking variables. You want to be cautious about data that's been aggregated too much, been shoved together too much, because that might be hiding some other things going on in the background. And that means we want to be very cautious with data sets or contingency tables that are aggregated. They may be and often are, or there may be and often are other lurking variables in the background or variables lurking in the background. And if they're not accounted for in the study, that can spell trouble. That can mean somebody's trying to pull something over on you, or they're not being cautious enough themselves. It can be inept. It can be that they're doing it on purpose. A lot of times if they have an axe to grind, or if they're, they have a policy they want to push forward, they'll ignore some of the confounding that goes on with other variables.